afternoon, everyone. This month's Wildlife for Lunch webinar is on patterns of fawn production, presented by Dr. David Hewitt, the Stuart Sidman Chair for White-tailed Deer Research at Texas A&M University Kingsville and Caesar Claiborne Wildlife Research Institute. The webinar today is made possible through funding provided by the San Antonio Livestock Exposition Incorporated, and it's hosted by the Texas Wildlife Association and Texas A&M AgriLife Extension. With that, Dr. Hewitt, I'll pass the controls over to you, and you should be good to go.
All right. Thank you, Clint. I appreciate everybody logging in, I guess is the right term for this webinar today. So we're going to spend the lunch period here talking a little bit about an important aspect of deer management, and that's the production of fawns. It's really the base of any deer management program, and it's something kind of easy to forget about because it's a longer term process, and when you're out in the hunting blind, you might be thinking more about bucks and you know, antlers and things like that, but all these things that we're interested in as deer managers are really going to be predicated on having fawns come into the system. So what I want to start with is just a few slides to help us get in the right frame of mind about the importance of fawns in deer management. Then we'll move into some research and things we've been learning about different patterns of fawn production here in Texas. So the first reason that somebody who's concerned with deer might be concerned also with fawn production is that to have deer in the environment, we need fawns to replace the deer that die. Deer die naturally, and so you need fawn production at least equal to the number of deer that are dying to keep a sustainable population. Now, if we're interested in hunting, we're going to add another mortality source to the population, and so we're also going to need fawns to replace the deer that we require, or that we're going to take through harvest. In even more, you know, kind of subtle sense, and maybe in a more direct sense related to hunting, fawn production is going to require, or it's going to be required if we're interested particularly in getting mature bucks. And it might seem like a kind of distant connection, but we need fawns on the ground in order to get these yearling bucks, and some of those yearling bucks are going to die every year, and so we need a fair number of them to get enough 2- and 3-year-old bucks, and some of those are going to die each year as they mature to get enough of the 4- and maybe 5-year-old bucks that then are going to be the basis of our mature bucks, these bruisers that maybe our management is going to really be targeting. And so again, you need these fawns in the pipeline in order to get enough of these mature bucks to meet your management goals. A couple other reasons why fawn production can be important. Fawn production, high fawn production, can open up some options for your management. One of these might be selective harvest, and in particular, maybe removing deer at younger ages that are kind of on the lower end of the distribution of antler sizes of deer on your property. And so if you've got a lot of fawns coming into the system, you're going to have a lot of yearling bucks and 2- and 3-year-old bucks. As a consequence, you now have the option to remove some of those lower deer, those smaller deer, those younger age classes if you choose, and in doing so, leave the better deer and invest in the better bucks, you know, as they move on toward maturity. Conversely, if you have low fawn production, your options are going to be limited. You're not going to have very many deer in that pipeline heading toward maturity, and if you shoot some of them as young deer, you're going to have even fewer mature bucks. They may be all right with that, but I think you're better off if you have a lot of bucks in the pipeline, and again, it gives you some more options. Another reason why fawn production, and this is more an idea of consistent fawn production, can be important, relates to the age structure of deer. And so what I've got on this graph are the proportion of deer, both males and females, in each age class from 1 year old up to 6+ years old. And so if you think about a population of 100 deer, maybe in this particular example, about 60 of those are going to be females, about 40 males. Males tend to have a higher mortality rate and may have some dispersal that could contribute to a fewer number of males. And then we'd have about 15 females, as you can see from the example down here of year-old females, and we might have about say 5-year-old females, and so I think you can kind of see how this graph looks. And the reason each age class is getting smaller up through 5 years of age is that we have some mortality in each of those age classes. So there's fewer number of 5-year-old than 4-year-old deer, and fewer number of 4s and 3-year-old deer. The 6+ category is larger than the other categories, mainly because we've got 6 and 7 and 8 and 9 and et cetera, older deer in those categories, so it's a little bit bigger. But this might be a typical age structure for a population in which we've got pretty consistent fawn production. I'm going to show you another graph here of a age structure for a population, and this age structure doesn't look anything at all like the age structure that we just talked about. We've got a big gap here in 2-year-olds. There's hardly any 2-year-old deer. We're not getting a big drop off as we get up into older age classes like we did above. And we've got a huge number of really old deer, 6+ year old deer. These data that I'm showing you here aren't contrived. These are actual data, and they're from a large property called the San Antonio Viejo Ranch south of Hebronville. This is part of the East Wildlife Foundation properties, and I'll tell you a little bit more about the East Wildlife Foundation as we get near the end. But what we've been doing on this property is capturing deer annually since 2011. And we told the helicopter pilot to just capture the first deer he comes across. Buck, doe, age doesn't matter. He's even catching fawns if he's seeing any. This particular year was 2011, and if you remember back to 2011, that was our real bad drought year. 2010 was a wet year. 2009 was another drought year. These deer in the 2-year-old age class that I have circled in green there, that's the 2009 cohort. There are very few deer in that. Had a fair number of yearling deer because 2010 was wet, relatively large cohort. Got a huge number of old deer, and what that says is that once these deer get into the population, their survival's relatively good, and particularly once they get to be older, they stay around a long time. But we've got these big gaps in the production, and that's kind of a feature of some of the fawn production patterns here in South Texas. And I think you can envision as this 2009 cohort, these 2-year-old deer in this particular example, as they age, and as that 2011 cohort comes through, which was very small as well, as it ages, we're going to have a period in a few years where there'll be a lot fewer mature deer because of this breaks in this production. So this age structure aspect has some real management consequences and something to pay attention to and think about. All right, so that's kind of a background to give us a reason to be thinking about fawn production and maybe put it onto our radar screen. And what I'm going to spend the rest of the talk doing is going through some different aspects of fawn production, kind of patterns of fawn production that have kind of come out through our research over the years here, and talk a little bit about the age of the doe and how that influences production, variation amongst does and their ability to recruit fawns, variation in fawn production from one year to the next, which we've got a little taste of just from that age structure graph, and anybody who's managed deer in Texas know, that's not going to be news to you. Fawn survival over winter, and then finish up with a little bit of management, kind of discussing some management techniques that might influence fawn production. So, start with pregnancy rates at the beginning of this fawn production process and the effects of doe age on fawn production. In the kind of early and mid 1990s, Texas Parks and Wildlife conducted just a massive study across the state for 3 years in which they harvested does in the spring and used those data to determine what % of the does are pregnant and the litter size, how many fetuses each of these does had in them. So we've got the different regions on the left-hand side of the table there. I've circled the % pregnancy and average litter size for 2 of these regions, the Trans-Pecos and the Edwards Plateau. These data are a little bit different than the other regions. The years that this study was done was particularly dry in the Trans-Pecos, so pregnancy rates were lower than other parts of Texas, and the litter size was low. They averaged 1 fawn per female. That changes if you get adequate rainfall. Edwards Plateau was a little bit lower as well than the other regions. 90% of the does were pregnant, and average litter size was 1.3. So really the main idea to take out of these data is that if there's a mature doe walking around in spring, she's probably pregnant. 9 out of 10 or even 19 out of 20 of those mature does are going to be pregnant in the population. Most of them will have twins. Some are going to have yearlings, so that they're going to have a single fawn, so that we end up with these average litter sizes of 1.5 to 1.7. But mature does, for the most part, are going to be breeding. I'm going to move into some other data now that will maybe give us a more refined picture of effects of doe age on breeding. And for that, I'm going to be referring to some data from a large research project we've had going on out near Carrizo Springs. And I'll be referring to it as the Comanche Faith Project. This particular project was conducted on 2 different ranches, the Comanche Ranch and the Faith Ranch. And each of these ranches built 6 200-acre enclosures. And so within the red lines there, on the Comanche Ranch, you can see several of our enclosures. I've got a number. Enclosure 5 is kind of off to the left of the screen. You just barely see a corner of it. But I wanted to present it this way to kind of give you a scale of this study. It's a big scale study. And there was a similar design of 6 200-acre enclosures on the Faith Ranch as well. So we had 12 enclosures as part of this study. Our interests were looking at the effects of supplemental feed, a pelleted type feed, on the deer and their production and demography and things like that. And also the effects of deer density on the deer themselves and on the habitat, on the vegetation. I'm really going to be focusing on some of the supplement data here, mainly because we just didn't find any effects of the 3 deer densities that we incorporated on any of the fawn production parameters. We conducted this study over 9 years, and so we've got a long run of data out of these different enclosures that I'll be referring to. So with that in mind, here's the first set of data that are going to come out of the enclosures, and my x-axis on this got altered a little bit, but basically we've got fawns, 1-year-old, 2-year-old, and 3+ or mature does on the x-axis there. And we've got data from the enclosures with supplement in the yellow, and data from enclosures that didn't have any pelleted feed in the green. And what you can see right off is that 2 and more mature does, 3+-year-old does, had 90 to 90, even 100% pregnancy rate. So whenever we got our hands on a doe in the spring, we would see if she's pregnant or not. And again, just like the Parks and Wildlife data suggests, nearly all these does are pregnant, all these mature does. If we look at the 1-year-old does, these pregnancy rates drop down a little bit, 80 to 90% pregnant, and so there is an effect of doe age, and these younger does are a bit less likely to be pregnant. In the fawn category, we've got a big drop in pregnancy. In fact, hardly any fawns were pregnant in enclosures without supplemental feed, and that's a pretty common observation if you've ever harvested doe fawns, and particularly if you don't provide a supplement. It's really rare to find them pregnant. You can harvest if you've got MLD tags up until late February, and that can be a valuable time to harvest does because you can learn a little bit about pregnancy rates. And when you do that in at least in South Texas, without the presence of supplemental feed, it's very rare to find a pregnant doe fawn. When we added supplemental feed to the system in our study, we got up over 30% of those doe fawns being pregnant. So this fawn age class is really sensitive to this better nutritional environment. Okay, we've got another set of data here that look not at pregnancy rates, but at which does are actually recruiting fawns. In other words, getting fawns till to a December time period, getting them to six months of age. And the way we did this is Aaron Foley, who was a graduate student at the time, and Randy DeYoung, who was a geneticist here at the Cesar Claiborne Institute, took the tissue samples that we collect off of every deer and used some DNA analysis, some genetic techniques to determine who mom was. And if we take all the fawns that we handled in the unfed enclosures and determine who mom was, about 85% of the time, I'm circling here, 85% of those fawns were raised by does that were 3 years old and older. The 2-year-old does and the 1-year-old does only accounted for about 15% of the fawns that we handled in these enclosures without supplemental feed. And we never found a fawn that had been raised by a doe that had been bred as a fawn. So those real young real young does just don't appear to be very good mothers. Even the 1-year-old does just weren't recruiting any fawns. And that same pattern happened in the supplemental feed. Again, about 85% of the fawns that we handled in these enclosures had been raised by an adult doe, and in both the fed and unfed enclosures, again, about 10% of the fawns in those enclosures had been raised by 2-year-old does, and relatively low fawn recruitment by does that gave birth or that were bred at 1 year of age. All right, we're going to take this one step further now and not look just at age class, but kind of look at individual does and their ability to recruit fawns. And we're going to focus on just adult does now. So these are 3-year-old and older does, and they're does that were in our experiment for at least 3 years. Some of them were in for 5 or 6 years or more. And what we've got across the x-axis here is the average number of fawns per year that individual does recruited. And this, again, is based on some of the genetic analysis that Aaron Foley and Randy DeYoung did from tissues we collected from the deer in the Comanche and Faith enclosures. So one thing that jumps out immediately is in this blue box here, there's about 45% of the does in these enclosures without supplemental feed that were just not successful at raising fawns. A little over 40%, we never detected a fawn in 3 or more years of data for each of those does. About 5% of the does recruited maybe 1 fawn over that period, so 0 to 0.25 fawns per year on average. And then if you look to the right, we've got a class of does that are going to be more successful, maybe raise a fawn every other year, and up here at this class with 0.75 to 1 fawns per year, we've got a small proportion of does that really seem to know how to do it in that environment and raise fawns year after year. So what about, this is for the does that didn't have access to supplemental feed. Yellow shows the same type of data for does that had access to supplemental feed. So we've got a big improvement in the number of fawns per year that different does are raising. We still have about 20% of our does that appear to be very poor at recruiting fawns. Again, we never or rarely detected any fawns that they recruited. So about 1 in 5 does in this environment just didn't seem to have what it takes. And then up on the right-hand side, we had does that raised fawns every year, and a couple of does that even recruited twins in some of those years. So what this says to us is there's some does that really know how to do it in this environment, and there's some does that year after year appear to be poor mothers and just don't have what it takes to produce a fawn in this environment. So got a little summary from this first section that we just walked through. Fawns are real sensitive to nutritional condition and are unlikely to become pregnant unless nutritional conditions are really good. Nearly all mature does bred, that's out of the Parks and Wildlife Study, it's out of our Comanche Faith data, and that's just a common finding any time that we've looked into this. Fawns and year-old deer appear to be poor mothers. They just don't appear to recruit very many fawns on their own. They get pregnant, they give birth, but they're just not very good at getting those fawns raised up. So most fawns are recruited by the mature does. And then after that, from that final set of data we looked at, there's some mature does that are really good at what they do in that environment and are much more successful at raising fawns, and there's some does that just don't seem to have it figured out. Okay, I'm going to move on to another pattern in fawn production in Texas, and this is changes from one year to the next. And I think what you see on this slide here kind of typifies what happens in Texas. We go from these dramatic swings of really maybe good conditions over the summer and seem to have more of these poorer conditions over the summer, particularly in recent years here. So in the upper right is a picture from one of our enclosures out near Carrizo Springs, one of our research enclosures in August 2006. And the lower left picture is from August 2007. August is an important time to look at if we're thinking about fawn production, because that's when the does are in peak lactation. Those fawns are going to be growing quick. They're relying heavily on the milk that mom's producing, and mom can produce milk if she's got the right food available to her. You can imagine a doe in that upper right picture in August 2006 having a pretty tough time. You know, all the herbaceous vegetation is basically brown. There's some shrubs there that had some leaves and all on them, but it'd be a pretty rough environment. 1 year later at that same spot, you can see flowering forbs in August. And so if conditions are right, Texas could be a wonderful place for a deer to raise a fawn. And if they're not right, it's a pretty rough place, and mom often has to just worry about her own survival and not worry about raising fawns. So with that in mind, here are some data from 2 ranches that didn't have any supplemental feed over this entire period. And this is kind of a typical pattern for fawn production in South Texas, all the way from the mid-70s up to 1996. We had some years where it was essentially a total bust on reproduction, less than 10 fawns per 100 does. And then they had some periods, at the upper end of the graph here, where production is about as good as you could expect anywhere in the country. And we jumped around from those from 1 year to the next, just tremendous variation. The average in at least a lot of South Texas, without supplemental feed, you might expect 30 to 40 fawns per 100 does on average. But again, a lot of variation around that. Tim Jeanette, who was out at Uvalde at the time, and Butch Young did a neat study using a lot of Parks and Wildlife Survey data, in which they evaluated different time periods to see when rainfall was important in fawn production. And for this study, they divided the state up into 8 different zones based on the amount of rainfall that fell during March through July. So the different colors on this map are the different zones. Got a red line running down through there, and that's roughly going to be a division between what I'll call West Texas and East Texas. And if we look at the 4 zones that are west of that red line, got zone 8 out in West Texas, and that's the all black zone there. There's kind of a hashed one just a little bit to the east of it. That's zone 7. And then you can see the other 2 zones there in the colors that they have. Over on the right side of the graph here, we've got a relationship between rainfall in March through July. And the axes are actually in millimeters, but I've put a kind of an inches conversion roughly in there, so 8, 16, 24 inches on that zone 7 graph. And then on the y-axis, we've got the fawn-doe ratios, number of fawns per 100 does. And you can see that particularly in zone 8, zone 7, zone 6, which would be West Texas and South Texas, fawn-doe ratios increase dramatically as precipitation in March through July increases. That pattern isn't as strong in zone 5, but it's there. So again, these dramatic changes in fawn production that we have from 1 year to the next are going to be influenced heavily by rainfall. Not a big surprise, but it's kind of neat to see it laid out that way, and how that rainfall effect changes as you move across the state. What about if we go to East Texas? These are the data from West Texas. If we move east of that red line, now we've got 4 more zones that are in East Texas, and you can see a really dramatically different relationship, particularly in zones 3, zones 2, and zone 1. And here, rainfall actually seems to cause a decline in fawn production. And so depending on where you are in the state, you've got different things that are going to be influencing the annual kind of pattern of fawn production. And there's some things that go on out in East Texas that if you get 24 or more inches of rainfall in March or July, you might expect a lower number of fawns than if you had less rainfall. All right, so that's kind of a no-brainer, and anybody who's managed land, particularly in South or West Texas, is really familiar with the relationship between rainfall and fawn production. Through some of our research, we've got an additional insight into a process going on that isn't as obvious, and we still don't have a good explanation for it. And our first recognition of this other process going on came from some of our deer capture data. So we had a long run of deer captures, particularly in Webb County, out near Laredo and Encinal and places like that in the western part of South Texas. And captured deer from 1999 up to 2007 on 4 different ranches out there. And something really interesting jumped out at us. There were some years that I've got roughly highlighted in green here where 30 to 40%, almost 45% of the bucks that we captured were yearling bucks. And so we told the helicopter pilot to go out and capture the first buck you see, and then, after we get our hands on it, then go back up and capture the next buck you see. And so essentially capturing bucks at random was the idea. And you can see this huge variation in the proportion of yearling bucks in these herds. I'm going to focus on one particular line. This is what I just kind of highlighted in red here, the data from a place out near Laredo in Webb County. And we've got some additional information from that ranch. That's why I'm going to focus on it. And you might be thinking, that's a no-brainer. We just talked about all this variation in fawn production. And so in a year where you've got high fawn production, the next year, all those fawns are going to recruit and you're going to get a whole bunch of yearling bucks. And so that's kind of a no-brainer. That's what we thought. But here is the data from fall helicopter surveys, and we've kind of rescaled it a little bit so that it represents the proportion of buck fawns in the survey. And so the orange line there is the proportion of buck fawns in a survey. And we've got these data, kind of aligned here. So I circled the first 2 points. That's the 1999 fawn data and the 2000 yearling buck data from the capture. And so that's one cohort. And they just grew up from being fawns in 99, and now that same cohort of yearlings in 2000. So you can see there's a big drop in the proportion of bucks on that ranch that are yearlings relative to the proportion that were buck fawns the year before. The other thing that really jumps out here is there were a few years right in here that I've highlighted in green, 2001, 2002, 2003, when we had these huge numbers of buck fawns. 30 to over 40% of all the bucks we caught, were yearling bucks. So a huge proportion of the population of bucks were yearling bucks in those years. But the proportion of buck fawns from the years before really doesn't change that much. And what's a real concern is what's going on out here, 2005 through 2009. Still the same proportion of buck fawns in surveys, so relatively high, fawn production in those years, but much fewer yearling bucks in our capture. So the only thing that we could think of is that something was happening in some years to these buck fawns before they got to be yearlings. And to try to get a better handle on that, we did a 3-year study in which we captured fawns in October. So about the time they were weaned, we would capture them. We put a little radio ear tag. You can see a picture of it in here, and we release those fawns. And we use that radio ear tag to monitor their survival over the winter. In other words, during this period when maybe we're having these problems with with these buck fawns basically disappearing before they get to be yearlings. And we've got our results right here. Chris Van Vogelen and Robert Kaiser were the 2 students that worked on this in 2008, 2009, and 2010. And as you can see, the percent survival of these buck fawns over winter was 50 to 60%. In other words, for every 100 buck fawns, 40 to 50 of those would die over the winter. This was a surprise. You might expect something like that up north where winters are really tough, but here in South Texas, that was a bit of a surprise to us. Charlie DeYoung had done some preliminary work back in the late 1980s and had some similar results, 65% survival over winter of these fawns. So this is a happening or kind of an event or process that's really under the radar screen. It's hard to know, when you're losing some of these animals. Predators and vultures, scavengers clean these carcasses up really quick. When these animals die, they may be killed by predators. Certainly some of them are. They're going to get eaten quickly. If they're sick, they crawl off under a bush and die. And so you just don't see these dead animals. And in talking to a lot of people across South Texas, they assume that the fawns they count in October are going to be yearlings the next hunting season. And our data is suggesting that in many years that's not the case. In some years, the survival may be really high, but at least in these years where we did this study, the survival is relatively low. What might this mean from a management standpoint? Maybe it's just a real kind of simple kind of population projection in which we assumed either 100% survival from fawns to yearlings, which is represented by what's in the green circle there, or a 40% mortality. And so if you start with 100 buck fawns, if you have 40% mortality, you've got 60 buck fawns the next year. And then we just assume 90% survival or 10% mortality of deer from 1 year old and older. And so that's kind of the number of deer that you'd expect in each of those age classes if you had 100 buck fawns entering the population every year. What this means is that if you take all the mature deer in this particular little population, if there was no winter mortality, in other words, that upper blue line, and you add up all the bucks that would be in the 4, 5, 6, 7, and 8 year old age category, you've got about 300 mature bucks. If you take 40% of those off the top as they go from fawns to yearlings, and then let them have the same survival rate as that blue line, we're down to under 200 mature bucks, 179 mature bucks that are 4 to 8 years old. So losing this 40% or in some instances 50% of these fawns from October until the next year when they become yearlings can have an influence on the number of mature bucks on your property. So got in many parts of Texas this large annual variation in fawn production and survival. Spring summer precipitation appears to be the primary effect on fawn production. Fawn survival over winter varies, so that some years a lot of a lot of yearling bucks come through, and in other years hardly any yearling bucks come through, even if fawn production the year before was pretty good. And so you're not going to want to assume that all the fawns you count in October are going to be alive the next spring and therefore get to the yearlings the next year. Okay, I'm going to kind of move in toward a final phase of the presentation here and talk about some management actions. And really a bulk of this is going to be on supplemental feed because that's where we've put a lot of our recent research efforts. Have some comments on predator control and fawning cover and some other management techniques that you might want to consider if you want to influence fawn production on the property that you manage. So here's some data from a ranch out in Webb County from 1987 out to 2009, and these are fawn-doe ratios. You can see a lot of variation like we've seen in some of these fawn-doe ratio things, but there's a trend there. And if we want to know what happened during that period and got that trend really kicked off, in the late 1990s, this particular ranch developed a feed program, a pretty intensive feed program. And so fawn production went from 20 or 30 fawns on average before, 20 or 30 fawns per 100 does before the feed program, up to maybe an average of 60 fawns per 100 does afterwards. So it may have doubled or even tripled fawn production, and still have a lot of variation going on there, but really seem to make a difference. Got similar data from our Comanche Faith Research Project. The yellow line on top there is fawn-doe ratios over the years from the enclosures with supplemental feed. The green line are fawn doe ratios without supplemental feed. So without supplemental feed, maybe an average around 40 fawns per 100 does. With supplemental feed, 70, maybe 80 fawns per 100 does, something like that. So again, roughly a doubling in fawn production. But one thing that really jumped out at us from these particular data are even when you start providing supplemental feed, you still get a lot of variation from year to year in fawn production. And this wasn't a subtle supplemental feed program. In these enclosures, we had 2 ad-lib feeders in the center of each enclosure. So this is a feeder, kind of one feed site for 200 acres with 2 feeders at the feed site. And you can see from the data here that even in that supplemental fed pasture, we went from 40 fawns per 100 does to near 100 fawns per 100 does. So just a dramatic variation in fawn production. 2009, 2011 were both drought years, and you can see from the fawn doe ratios in these enclosures with supplemental feed, those were low years of fawn production. And so supplemental feed doesn't take care of this whole deal. It raises it, but the rainfall and the habitat conditions are still having a big impact on fawn production. So that's one lesson. Another thing we might be able to get, or another thing we can get out of this Comanche faith data, is looking at fawn survival from 6 to 16 months. So that's kind of from this November, December period until the following September about is what these data represent. And you can see supplemental feed makes a big difference. They go from about 85% survival in the presence of the supplemental feed, and without supplemental feed, we're below the 60% survival. So the supplemental feed can have can increase the survival of these fawns after weaning pretty well. If we remember back to the data that Robert Kaiser and Chris Van Boegelen got with the fawn survival over winter, 50 to 60% survival. That's really not all that different than the 60% survival that we have in the enclosures without supplemental feed. The interesting thing is that the data that Robert and Chris gathered was from a ranch that had a well-developed supplemental feed program. They had a feeder every 200 to 300 acres and still had this relatively low survival over winter. So kind of wonder what's going on there. And got some insights from a variety of different sources of data. One insight comes from looking at the number of fawns per 100 does in the helicopter surveys, and this is just from a single year. So counting does and fawns from the helicopter in this particular year, 51 does, fawns per 100 does. Then we ran cameras at those feed sites for the next couple months after that, and we counted the numbers of fawns and does in the pictures, and we only got 10 fawns per 100 does at the feed sites. So there's some evidence that the fawns aren't showing up at these feed sites at nearly the same rate that the does are. And this was substantiated. Remember I said we had those little radio ear tags. So we had some fawns out there. We knew which fawns they were. And over the 2 years that Chris was working, only 10% of those radio tag ear fawns were ever photographed at a feed site. So even though there were a lot of feed sites out there, these fawns just weren't getting access to it. Some reasons why fawns might not get access to this supplemental feed. One is that fawns are relatively low in the social hierarchy. And from some of our another research project out on the Comanche Faith Ranch, Robin Donahue was a graduate student who looked at social interactions at the feed sites. And he quantified interactions between deer, and then when there was an interaction, which deer won, was it a buck or a doe, and the age. His conclusion is that of all the hundreds of interactions he looked at, fawns lost every interaction they had with an adult deer. You see the little guy in this picture, you can tell he's just hating. He's getting beat up by that doe, and he's got his eyes closed. It's just ain't any fun for him. And so you'll see fawns eating supplemental feed, but I think it's a stressful deal for them, and they just don't come in at the same rate. And part of the reason may be because of these social interactions at the feed site. It's another reason why fawns may not show up at feed sites nearly as often as other deer. And there might be some aspects of our feed site designs that are causing problems for fawns. You look at this little guy in the upper left-hand corner, he's kind of looking wistfully up at that pelleted feed up there in the spout, but it's not designed for him to be able to get it. And so you'll often see fawns eating the pelleted feed off the ground because the feeder just isn't set up where they can really get access to it. Another thing that was common in a lot of our pictures is to see this. We've got these fawns standing outside the feed pen, in other words, outside the fence that was put up to keep hogs and javelina and other animals out of it. And then you've got mom inside here eating. And so again, there might be some evidence that the design of our feed pens might be making it difficult for fawns to make use of this resource. Chris Van Bogen, when he was doing his project, looked into this in a little more detail. And what he did, he took all the feed sites that were in his study site, and he recognized that the lowest point in the pen surrounding the feeder, the lowest fence height, it varied from one feed site to the next. And so he measured the lowest part of the fence on each of these feed sites. And that's what's on the x-axis, this little graph in the upper left-hand side of the slide. And then he ran cameras at all these and recorded the number of pictures of fawns in each of these. And he got a pretty distinct break point at about 33 inches. Above 33-inch fence height, the number of pictures of fawns at these feed sites dropped off quite a bit. Below 33 inches, we're getting a fair number of pictures of fawns. There's one data point up here in the upper left at 35 on the y-axis there. That 35 represents the number of pictures of fawns that was at a feed site that did not have a fence. And so this is some evidence that, yeah, these fences are probably keeping these fawns, particularly, in the early part of the winter, maybe when they're in the process of being weaned, from getting access to that supplemental feed. Had another kind of inspiration then, and a couple of the students worked on this. If you look at the lower right-hand picture, we've got a gap cut in the fence around there. This gap is designed so that there's about a foot or 15 inches of fence still at ground level. That keeps little pigs out, keeps javelina out. Then there's a gap cut open that a fawn could get through, but a big pig probably can't. And so the idea was to make these little gaps that fawns could hop through, get access to the feed, and get back out. But the fence would still be serving its purpose to keep non-target animals out. I had an undergraduate student do a little project out on her ranch to look at the effectiveness of these gaps. And she had a feed pen that is called the control in this little graph up here in the upper right. And she ran cameras at that and got an estimate of the number of fawns per doe, pictures of fawns per doe in there. And there's about, for every 100 pictures of a doe, there are about 20 pictures of a fawn in there. When she put in this modification in the feed pen, all of a sudden the number of pictures of fawns per doe jumped up, about 70 pictures of fawns for every 100 pictures of a doe. And that data was similar to a feed pen that did not have a fence around it. So some evidence that, yeah, these fences may be one of the reasons these fawns aren't getting access to that supplemental feed. And if there was one class of animal that you might really want to make use of that supplemental feed, it's that fawn. That fawn's growing, it has high nutritional requirements, and its nutritional environment, when it's small like that, can set up kind of its approach to growth for the rest of its life. And if it's living in a tough environment when it's a fawn, its body physiologically sort of says, hey, you don't want to get really big in this environment. This is an environment that can support a great big deer. So let's stay small so we can stay alive. Conversely, if that fawn is in a really good nutritional environment, then its body says, holy cow, this is a great environment. Let's grow big. And so I think there's a lot of reasons why you'd want to try to influence the nutritional environment of those fawns. So supplemental feed and management practice. Improving nutrition does improve fawn production. However, the supplemental feed does not alleviate this environmental variation that we see. It can improve fawn production, but you're still going to have typically better fawn production in good wet years than you are in dry years. Fawns may not get access to the supplemental feed that could be contributing to this overwinter mortality, could be influencing the fawn growth rates, as they continue to mature. And so designing feed sites with fawns in mind may be something that you'd want to think about. A couple last thoughts here, and then we'll wrap it up and get to some questions or comments. Predation is another aspect that surely impacts fawn survival and fawn recruitment. Coyotes, bobcats eat fawns, there's no doubt about it. Been some neat work done in Texas showing that if you remove coyotes, particularly at the right time of year, right before fawning, that you can influence fawn survival, you can increase it. However, there's also been some studies that were just as intense here in South Texas over several years that just couldn't find any impact of removing coyotes on fawn production. And so, it's like many of our management techniques, I guess, maybe it's real site and situation dependent. I know some places that invested a lot in removing coyotes and didn't see a bump. I know other ranches that do that annually every year and invest a lot of money in it, and they've got great fawn production. So they feel they're really getting something from it. So the predation thing is a bit up in the air. There's been some research done, but there's nothing real conclusive. In contrast, the supplemental feed does seem to be a real consistent, or is able to influence fawn production consistently. Maybe you don't want to kill coyotes, but maybe you want to do something to make the world safer for fawns that are born on your property, and fawning cover would be a logical one to do that. It sure makes sense that coyotes and bobcats are going to have a harder time finding fawns if those fawns have a lot of cover as opposed to not having cover. So I think that makes a lot of sense. It's hard to know what mix of cover, what type of cover really could benefit the fawns, and it's hard to even know how much it benefits the fawns because there's just never been any work done on it. And the years where we tend to have a lot of fawn cover tend to be wet years. They also tend to be years where the nutritional environment's really good. So it's hard to know if the fawning cover improved fawn numbers or the nutrition improved fawn numbers. There's a real need for some research on this, and let me tell you why I think this is true. Because this is a situation where a manager can do something, and one of the things they could do is go out and manage their habitat to produce fawning cover. And there's places that have done a lot of brush work and then seeded behind with a grass like buffalo grass that's really good at producing cover that fawns could hide in and could even grow in pretty dry conditions. So you could make some fawning cover during a year when it's really dry. The trade-off of doing that is these grasses that fill in really heavy like that and might make really good fawning cover tend to choke out all the forbs and a lot of the other food that the deer, that doe, is going to have to rely on. And so if nutrition is really the limiting factor, then getting rid of a bunch of brush and getting rid of the ability of the land to produce forbs would be the last thing you'd want to do. If it's predation and fawning covers was lacking, then doing some of this habitat management to improve the fawning cover would make a lot of sense. Our problem is we don't have a good idea of how that plays out, and that'd be a place where research really should focus here next few years. So, wrapping things up here, need to thank and acknowledge the Comanche Ranch and Faith Ranch projects. Colleagues Charlie DeYoung, Tim Fulbright, Donnie Dreger, Kim Eccles, and Randy DeYoung, and Comanche Ranch and Dan Freakin and the Faith Ranch and the Stedman West Foundation for all the resources they put into that project. Nate Cook and Aaron Foley were graduate students that got a lot of the data I presented today. They've got that data together. Also need to acknowledge those who participated in the deer captures and funded the deer captures that we did in Webb County. Those people are listed there. And then, as promised, I want to say just a little bit about this East Wildlife Foundation, because the East Wildlife Foundation is really set up to do some neat things here in Texas. It was originally established as a private operating foundation from the estate of Robert East, and is designed to integrate research, education, and my slide got cut off there, but certainly a lot of research and education to support their missions. Got over 200,000 acres across South Texas, all the way from the Gulf Coast to the San Antonio Viejo property south of Hebronville, that is where I presented some of the data from. Got a mission of helping the public understand the benefits of ranching and private land stewardship, and doing this through education and research. And there's a website to these foundations if you want to learn some more things about their activities. And with that, I will pass it back over to Clint, and I'd be happy to spend time answering any questions that you all have.
All right, thank you, Dr. Hewitt. We have a few questions and a few more coming in. As we answer these questions, I encourage everyone to continue posting questions. We still have a little bit of time, so we should be able to get to quite a bit. The first question is, do you have a feel for the percentage of deer mortality that is due to traffic collisions and from getting hung up in fences? It seems like we have a large number of deer dying from these causes in our area. Curious if if this is a major cause of mortality compared to predators and natural causes of death.
Yeah, that's a great question. Most of my experience, actually all of my experience, is in South Texas, and so I think the deer that we've studied have been less susceptible to those types of mortality sources than in other places in Texas. That having been said, we have had our collared deer get hit on public roads. We've had them get hit on ranch roads, and we have on 3 or 4 occasions had deer hung up in fences. All the deer that we've had hung up in fences had been yearling bucks, and maybe they're smaller, so they're gonna have a harder time maybe clearing a fence than a mature buck. And they were also in the process of dispersing, and so they were in some country they just weren't familiar with, and again, being a smaller animal may have been more susceptible to that. That having been said, I don't have a good kind of understanding or take on the proportion of mortality that's going to happen to those kind of accident type causes. Other than at least in our environment, I think it's less than kind of natural type mortality, whether that be disease or predation.
Okay. The next two, I believe, are in regards to the fences and fawns. It says currently on our property, we have cut 3 squares out of the top panel of the fence surrounding feeder locations, and have done this about 10 to 12 locations for each feeder site. Do you have any information on that type of fawn access? Is it beneficial or not?
I don't have any direct information, although based on our, on the findings that the likelihood of fawns using a feeder is dependent on the fence height, I'd predict that would be a benefit. If you're reducing the fence height, in some places in those feeder pens, I would predict that would help the fawns get access. And if you've got, if the participants have any insight on that, that'd be a good chance for us to gain a little bit from the observations in the field.
Okay. The next says the gap between posts for fawn access seemed to be about 8 to 9 inches wide. Can you confirm this?
Yeah, and that's about right. I think it was, look back at the slide, I think it was about 2 of the panels, or 2 of the squares wide. And so and I think they were 4-inch squares, so the 8 inches would be about right.
Okay, next question we have says we have been feeding 3/8 sheep and goat pellets to our deer, 20% protein, I think. Is this a good supplement, or what is preferable? Corn seems to be less nutritious, even though it appears to be the most commonly used.
Yeah, so, deer are not sheep and goats, and there are some kind of physiologic differences. That having been said, I would expect the deer to benefit from the type of pellet you're talking about. The protein level can have some influence, but I think really what the deer get the most benefit out of is the energy in that pellet. And I say that because deer, being a browser, tend to have a higher level of protein in their diet than, say, a sheep who may be focusing more on grazing, and particularly in dry periods, may be eating a lot of grass, with lower percent proteins. And so some of the domestic species may benefit more from a higher level of protein. In reference to the corn comment, you're right. Corn is used a lot. I think a lot of the feeding of corn is baiting, particularly during the hunting season. But there are plenty of people that will provide it outside of the hunting season. And to the extent that energy is limiting, that corn is providing some benefit. And it's going to be less expensive. It's not going to have the minerals in it, which a lot of the pelleted feeds, that's a real benefit of them, is they're going to have some phosphorus and calcium typically added in, and and so the deer can be benefiting from that as well. But the deer, if it's corn or nothing, providing some corn probably isn't, you're not hurting yourself, and I think there's some reason to believe why it would do some good. If it's corn or pellets, then I think the pellets do have some advantage, and they are higher in protein and will typically have the minerals mixed in.
Okay, and then one last one for now. Again, we still have some time if y'all want to post any more questions up. This is in regards to some research that was done on Asa Wilson's master's project. What implications did it end up showing? What I mean is, I know that we measured fawning cover every time we encountered a fawn ranch, but did that data end up showing greater fawning rations in one given year versus another? Were there more fawns located in a year with greater fawn cover than others?
Yeah, so that's a good question, obviously coming from somebody who participated in some of our Comanche Faith project. The extent that we've worked that up was looking at places where fawns were bedded relative to kind of random places in that same general area. And the fawns selected areas kind of adjacent to a shrub and with more herbaceous cover. And so so that's some indication that these fawns are actively trying to bed down in somewhere where their outline's going to be broken up and they could be hiding from predators. We haven't, and I don't know if we've got the sample size to it, but we haven't related, say, survival of the fawns to the fawning cover. And that would be a neat exercise to do if we've got sufficient data to do it. But Dr. Fulbright here at the Cesar Claiborne Institute, Tim Fulbright, was in charge of that project, and he'd be a better one if you wanted some more details on the fawn bedding site project. He'd be a better one to talk to on that.
Okay, I think that's all the questions we have for now. For everybody who's still on with us, I encourage you to fill out the survey at the end of the webinar. The info that you put in the survey is greatly beneficial to us in planning future webinars and seeing how we did on this one. Also, you can view this and any of our other Wildlife Lunch webinars at the link that I posted in the chat window. So if you want to go back and reference any of the material that was talked about today, or see any of the other webinars, if you may have missed one, you can follow that link and check us out.